Hey guys, so we're going to talk about logarithms. Like, what is a logarithm? First of all, it's a funny word. I get that. We abbreviate logarithm and we just write log. You can kind of see that here. So logarithms are used to find the value of exponents. Write that down. So what does that even mean? Well, think about what we already know. We know that 2 to what power equals 4? Well, you know that x equals 2. And you know that 2 to what power equals 8? Well, we know then that x would equal 3. But what is 2 to what power equals 7? So we don't exactly know what that is. It's not a whole number, so it's not something that, we can do just in our mind. What we do know, what we can infer, is that it's going to be somewhere between 2 and 3. Okay, because 2 squared is 4, which is less than 7, and 2 to the third power is 8, which is more than 7. So 2 to some power between 2 and 3 would give me that 7. So the way that we can evaluate this is, notice we have log base b of a equals c is equivalent to b to the c power equals a. So this base, your log base b is how you say that, is the same as the exponential base. And whatever the exponent is in your exponential function is what your log equals. So if I wanted to practice rewriting this, let's just use this that we're familiar with, like this 2 to the x equals 8. So that's my exponential function. The base is going to stay the same. So now I'm going to have log base 2. And now it's going to be equal to that exponent. What really happens is these two things, they switch places. They switch sides of the equal sign. So now I'm going to have 8 equals x. So log base 2 of 8 equals x. That's how we would write that as a logarithm. Okay, so let's practice this. The first example is 2 to the third power equals 8. These are all true statements. We know that 2 cubed equals 8. So the base here is 2. So when I write this in log form, I'm going to have the word log, and then the base is still going to be 2. And then these two numbers, these two values, switch places. So now I'm going to have 8 equals 3. The next one, 3 squared equals 9. So now we need the word log in our problem. The exponential base of 3 becomes the log base of 3. And then these two numbers switch places. So now we're going to end up with 9 equals 2. So log base 3 of 9 equals 2. This is basically saying this right here, 3 to what power is 9? Well, 3 to the second power is 9. So we know when we have negative exponents, it turns that into a fraction. 8 to the negative second is really like 1 over 8 squared. So that's how we're getting this answer of 1/64. So if I want to keep consistent here, the base is 8. So now if I'm changing this to log form, log, keeping my base of 8, and then these two values are switching places, negative 2 and 1/64. So 1 over 64 equals negative 2. And these also work with fraction bases. Okay, these are all true equations. Remember that. So now the base is 1/3. We know that it's the base because it's the thing that has the exponent with it. So now I'm going to change this to log form. So we need the word log. The base is 1/3. When we're writing this base, notice that the 2 and the 3 and the 8 and the 1/3, they're all subscripts. So instead of exponents, which are superscripts, they're little numbers high above, subscripts are little numbers down below. And then these two numbers, the 2 and the 1/9, are going to switch places. So now I'll have 1/9 equals 2. So 1/3 to what power is 1/9? That's where we're getting that answer of 2. Okay, so now we're going to practice going the other way. So we're starting the log form and we want to change this to exponential form. Remember that these are all true statements. So this log base 3 of 243 equals 5. Understand how to say that. Log base 3 of 243 is 5. So what does that mean? 3 to the 5th power is 243. So keep in mind what that looks like. The base here is 3, so that means my exponential base has to be 3. And then these two numbers are going to switch places. So now I'm going to have 5 is the exponent, and that's going to equal 243. And you could type that in your calculator and verify that. 3 to the 5th power is definitely 243. So looking at the next one, base 8, log base 8, we're going to have exponential base 8. The bases are not changing. These two values are going to switch places, so that 1/3 now becomes the exponent, and it's going to be equal to 2. 8 to the 1/3 power is 2. That's, again, a true statement. Now we're going to talk about special properties of logs. Notice here that we're taking log base 9 of 9. Those are matching. Anytime those are matching, that's going to equal 1. And why is that? Well, take a look here. That log base is 9, so that means the exponential base is 9. And then these two values will switch places. So the exponent becomes 1, and that means it equals 9. So 9 to the 1st power is 9. That's why when these two values are matching, it's always going to equal 1, because you're trying to figure out what power is going to give me back the same number as my base. Anything to the 1st power gives you back that same value. So now this last one here, I have a base of 3, so that means I'll need an exponential base of 3. These two are going to switch places, so the exponent is -3, and that means it equals 1/27. Think about the truth of that statement. 3 to the -3rd power is 1/27. That 3 to the -3rd is really bringing that to the denominator, 1/3 cubed, and that 3 cubed is what that 27 is. Okay, so let's talk real quick about exponential functions that we've been working with. And this b right here, the base of your exponential function, always had to be positive and not equal to 1. Always had to be positive because that a value is going to tell you if it was negative or not. And then always can't equal 1 because a base of 1 isn't going to be an exponential function anymore. So that rule has to apply to a logarithm also. So b is always positive and not equal to 1. And so what that's going to mean, that's going to mean that you can never take the log of a negative number. So this means a cannot be negative, okay, because of the restriction on your base. So let's see why that is. So these are equivalent statements. We just kind of saw that. Now log base b of a equals c and b to the c power equals a. So if we're saying that the base always has to be positive and not equal to 1, let's kind of put some numbers in here. So let's say our base is positive 2 and our exponent is 3. Well, now that means that a right here, this number, is positive. Okay, when we have that positive exponent, we get a positive answer. So a is never going to be negative in that case. Well, again, keeping consistent with the fact that we have to have a b value that's positive and not equal to 1, let's use that 2 again. Well, now let's say instead of a positive c value, now let's have a negative c value, so -3. Well, what's that going to do to my answer? That's just going to change my answer to 1/8, which is still positive. So notice that it doesn't matter whether that c value, whether that exponent is positive or negative, it's just going to give me a fraction instead. So that's why your a value, this guy right here, is never going to be negative. You can't take the log of a negative. It doesn't exist. And that's coming from the properties of exponents here. It just doesn't work. Right? When you have a positive base, when you take it to a positive exponent, you're going to get a number that's bigger. And when you take a positive base to a negative exponent, you're going to get that number that's smaller, but you're not going to get a negative value. Okay, so a couple of special logarithms. I kind of already talked about when these are the same, it's always going to equal 1. And that's just coming from, if you change that to exponential form, you can kind of see that right here. B to the 1st power equals b. So if we put some numbers there, like log base 3 of 3, since these are matching, that's telling you it's going to equal 1. And then if you use those same values and you change it to exponential form over here, now we're going to have 3 to the 1st power equals 3. So That's one special property. Another one is anytime you take the log of 1. So we're taking the log of 1 right here. It's going to equal 0. It doesn't matter what your base is. And that's again coming from this exponential form. Changing that, now you have b to the 0 power equals 1. Well, remember properties of exponents, anything to the 0 power is 1. So we can put an example here and say, I don't know, log base 7 of 1 equals 0. And if we change that to exponential form, now we have 7 to the 0 power equals 1. So anything to the 0 power equals 1. That's where that's coming from. Continuing on with these special logarithms, we have some common logs, just some things like, for example, when we have the square root of x, there's really a little 2 right there. We just don't write it. When we have x, there's really a coefficient of 1 there. We just don't write it. Again, there's really an exponent of 1. We just don't write it. So along with that, when we have a logarithm, when we have base 10, so we're thinking like log base 10 of, I don't know, some number like 14, we're not going to write that base 10. What you're going to see is you're going to see log of 14. And your calculator can only evaluate log base 10. So I'm not going to mark off if you write log base 10, but you can never type that on the computer. And then this log 14, you have to be able to realize that when you see that, there's really a little teeny tiny 10 in there. Another one we have is the natural logarithm. Natural logarithm we write as ln, and the natural logarithm is base e. So you'll see things written like the natural log of 3, and what that really means is log base e of 3. So we never write log base e. You need to get used to always writing that as natural log.